we're now recording. So to catch up on the recording, what I'm trying to do is I'm trying to go from author to orders to work out how many customers are being are reading these particular authors. And what I'm doing is I'm going, in this case, the first spot is to go from author up to book author, and I'm showing a very old syntax. I'm showing, I don't really know what the number is, but basically one of the original SQL syntaxes for basically pulling information from one table and another table, specifying how they join together. This is actually called the join condition, all right? Because the other thing I could have done here is I could have said, and the author dot author ID is equal to S100. That's not a join condition, that's a straight restriction. All right, so this is the actual join condition. And many times, by the way, what we'd be tempted to do with join conditions is put them in parentheses to sort of make them stand out a little bit more. All right, there's one more thing I got to do to fix this up to get it even to the ancient original standards. Most of the time, we don't put the table name in front because we actually a lot of times have table names that can be up to 30 characters, and sometimes the characters are crazy. They can have dollar signs, underscores, hash signs, and sometimes you're dealing with computer generated objects, and so you don't usually want to have to constantly repeat, especially back in the day that this was done on the mainframe and stuff like that, where you couldn't just simply do a copy and paste. So what we came up with was something called a table alias. So what I normally do, it's unfortunate it's going to be, well, actually, it's a big case, is you give it a sort of a shorter name. Like in this case, I'm giving it A. And in this case, I'm going to give it a BA for book author, right? And then what I do here is I'd say where A.author ID is equal to BA.author ID, and where A.author ID is equal to that. Now we're actually doing pretty good. And so the other thing I do at this point now is maybe bring in my projection just a little bit and reinforce the idea that these are coming from the author table. These are coming from the author table. And in this case, the ISBN, we'll just say I need it, is coming from the BN, is coming from the BA table. Let's just run it. And so now I got my little projection. Okay, and that's a lot of what the syntax is actually in the book. Now, if you don't mind, I'm going to take that restriction off for a second. I'm just going to keep it a straight and easy join. And obviously, I want to probably do some sorts and things like that as well, but we're not even close to being where we want to be yet. So, if you want to be cool and you want to use ANSI 92 syntax, you wouldn't do it like this. What I'm going to do is I'm going to highlight, I'm going to go copy, I'm going to get rid of this, I'm going to go paste, I'm going to come up here, and I'm going to type in old syntax, and I think the book had a nice name for it, which wasn't quite old, but maybe classic is I think what the book called it. So I tell you what, let's just do that. Classic syntax. But we're going to go and create ANSI 92 syntax, and from this point onwards, I'm only going to be doing it in ANSI 92. All right, so ANSI 92 syntax, how would this be done? What you do is you basically specify the first table in the from, and then you say join to the table book author on that condition. Now, what I want you to notice is, okay, what's going on? We're missing a semicolon. That's why it's mad. There's a semicolon there, put a semicolon there. Okay. So what's going on here? There are 3 clauses in the classic syntax. There are only 2 clauses in the ANSI 92 syntax, because all that is in the from. All right. I made the, I did put it all on its own, each on its different line, because I like to break it up like that. But, you know, logically, I guess you could argue that that would have been fine too. but because I'm used to dealing with larger table names, that just becomes unwieldy pretty quickly. So a lot of times what I'll do is I'll have the join, and then the on will be basically pushed back a little bit so that the ends line up. Right? But you don't have to be as anal as me. But anyway, so let's first of all make sure this thing works. And it does work. Now, actually, no, that's good enough. That's good enough for that. So that's the ANSI 92 syntax. I tell you what I'll do with this piece of syntax. I'm going to go copy. I'm going to put it out onto our D2L site just so you can see what I'm talking about. So let me just do that quickly. Oh, I'm a student. I don't want to be a student. Oh, look, yet another person's out there waiting. All right, good deal. All right, move that out of the way. Do this. Okay, move this guy in with a new announcement. And so what I'm going to do here, we're going to go classic versus ANSI 92. And I'll just put that out here in pre-formatted way. All right, there we go. So please definitely look that over. Oh, look, the indenting's all gone. Okay, I'm not going to adjust it now, but anyway, I want you to understand that is 3 clauses. That is 2 clauses. The select is still a projection, but now the from has been a lot more, interesting. And now, by the way, the word join condition probably makes more sense because you can see this is all part of the join. All right, so we now bid a fond farewell to this and move. Actually, before we do, let's go back to the original example. I'm going to go and I'm going to bring back that idea where I'm only pulling S100. So that's the author ID, right? So and the A dot author ID is equal to S100. So it would be an interesting question. Of course, it's bad because it's semicolon. So let's get back to that. We know what the result looks like. It looks like that. It'd be an interesting question to say, well, how would you do that here? Now, what you could do, and what that in the beginning, what a lot of newbies did do, is they went ahead and they put a where clause there. They basically put effectively this where clause back into it, but without the join condition. So this is one way to do that, and it would syntactically work, but you'd feel a twinge of shame because you're actually making the database work harder than it has to. The preferred way to do that in a join scenario is to go and. So what we're basically saying is pull everything from the author table, join it to the book author on this condition and that. So you could be thinking to yourself, what's the big difference? And here's the big difference. If I left off that end, forget the left off that end, I'll just do it here. So if we look at the way this query works, or if I left that as a where clause, what that would do is basically grab all the rows here, join it with all the rows here, and then strip out the S100s. That's a lot of work, right? I don't think any of you would want to do that. If I basically sat there and put you in a room and gave you this spreadsheet and gave you this spreadsheet, I said combine everything. You come up to me, about an hour later, go, I'm finished. And I said, okay, now can you just tell me what the S100s were? You'd be pretty upset, right? So what this thing actually does is it basically says, and this is where you got to remember, SQL is a language that gets interpreted and made into programs. What this thing basically does is it goes and grabs book authors that are 100 and then does the join. There's some neat background processing there. And I used to do some experiments, and I could tell you that this query would run faster than this query. Nowadays, at least in Oracle databases, it's smart enough that if I actually fed that to an Oracle database, it would actually know, whoa, dude, I'm not going to do all this work first. First of all, I'm just going to go grab all the authors that are 110 and then find all the books that belong to that author. That's what it would do now. But back in the old days, what it would do first is it would do the combination and then do the restriction. So The and is pretty cool, and this will make you more valuable if you try to get a job, right? So ANSI 92 SQL and the idea of using an and are some of the sort of the bigger learning objectives for that. All right, so we're good. Let's go back and look at my picture now because where's my picture? Because so far we've made it to here. I probably won't go as slow as I start to move along, but I basically know what the ISBN is. I'm now going to go over and I'm going to get the book title, the books. What's the join condition between these two? Probably a good deal just to simply look to see are there any keys, and there certainly are keys. Here's a primary key here. There's a foreign key there. They happen to have the same name. That's good design, by the way. It's not, doesn't have to be. I mean, this thing could have been called ISBNs, and this could have been called book code. But thankfully, whoever designed this basically said, hey, let's pick the ones that are equal. Let's make the names equal. So let's go back to here and start adding a little bit more onto that. I'm going to look over at my screen, my other screen here, and I'm going to basically add another join condition. I'm going to go join on books, which I'm going to anticipate. Is it books? Yeah. By the way, do you see in this model, for you guys with your models, understand how gross this is. Books, orders, customers, but yet this is publisher and author. I know probably at least once, probably once every 2 classes, I get tripped up on this, but I honestly think that the table name should be the plural of the subject that it's storing. All right. Maybe this doesn't have to be plural, but even order items is plural. So I would call that book authors plural. All right. So because it's just future developers are going to get more and more cheese at you all the time as they start going, well, why did this guy say author here and orders here? So be consistent in your stuff, but I think consistency would be pluralized. All right, that's the gospel according to Grant. Now we're going to keep going. So I'm going to give it the table alias of B. What's going on here? Why do you give it so much space? A lot of times what I like to do is line up my table aliases. All right, so what am I doing? I'm joining on the condition. On what condition? Well, a lot of times what I like to do is I like to basically put the primary key on the left, which is the book's ISBN number, is going to be equal to the book author's ISBN number. Okay, case is not that important. Let's have a quick look at that. Does that still work? It does. Let's pull in some information and pull in the book title because that's just kind of interesting. We go. That's looking good. And then what we'll do is we don't really care about the ISBN. We'll strip it out, showing again that, of course, you can restrict, sort, other columns that or other commands that we don't know yet on stuff that you're not projecting. This is simply what you want to see. This is the engine that's producing the data set. So I'm going to go, and that's awesome. So we got the title. Let's move a little bit further along the path. We're books. We're going to go to order items. Yep, and we can't stop there because we're trying to figure out how many, the customers that are reading these books. So we actually are going to have to go to customers because we're probably going to want that last thing. So let's go to order items next. And so we do a nice little join again. Join, and this one's okay. Forget the case. Don't worry about it. Order items. Jeez, no, I can't do that. I can't do that. I just can't. There it is. Order items. And a reasonably good alias for this would probably be OI. And what's the condition here? On. So what's the primary key in this case? Well, and you don't have to be a primary key, but I'm pretty sure in this case, I'm going to go where the book ISBN is equal to the order items ISBN. So where the book ISBN is equal to the order items ISBN. And is there any useful information in there that I care about? Quantity. Let's care about quantity. So I'm going to go up here. I'm going to grab the order item quantity. Okay, I'm going to go, and it worked, but we have an interesting problem. So let's do the pinning thing. I'm going to basically comment this out. I'm going to comment this out. So we originally, we basically had 3 rows. when we were basically going from the author to the books to the books. Okay, so author, book author, and books. At this point in time, we've got 3 rows. What this means is that Sam wrote 3 books. We're going to pin that. Now, as we start to bring in order information, it's dropped down to 1 book. What in English does that mean? It means nobody's reading the other books, or at least no one bought them, right? Body build in 10 minutes a day is the only one that's actually on an order. The other guys, how to get a faster pizza and the walk way to cook, no one's bought that book. All right, and that's kind of important to our query. So we're going to say goodbye to the walkway and the pizza book. Now we're basically looking at, that's the apparently poor Sam, in the entire history of this database, he sold 1 book, and it's his bodybuilding 10 minutes a day. That's what that means. Always when you're writing your query, don't get like code blinded. Like, understand what is the result telling you. What are you asking, and what is it telling you? All right, so the order items is done. We're not finished, of course, because we got to make our way over to orders, mostly just to pick up. I guess we could pick up the date. It'd be nice to know the date, I suppose, that Sam sold that book, but we're really trying to get to the customer. So I'm going to go look at my code again here with the thing. So this is, where am I? I was at order items, so now I'm going to orders. All right, so I'm going to join on to orders, which I'm going to alias as O. That looks weird. Alias is O, and it's going to be on the condition. And in this case, where's the primary key? Again, it doesn't really matter. It's the style choice. But I'm going to basically say where the order primary key is equal to the order number as the foreign key. That's what I'm going to do. So I'm going to go where the O dot order number is equal to the OI dot order number. Close it up. Let's run the query. And thankfully it didn't drop off. I didn't expect it to drop off because that would be quite nasty. If it could find the order here and couldn't find it here, we would be in violation of the whole relationship, right? We would have an order that doesn't exist, an order line or order items line that doesn't exist in orders. So I didn't expect anything to drop off. What I'm going to do now is I'm going to grab that order date. So O dot order date. That's what I'm looking for. Yep. And I'm going to go. And so now what we're seeing is that Sam managed to sell 1 copy of his book, wow, 11 years ago, right? So he's not making a lot of money on this, at least with us. All right, that's great. Now we probably want to know, who did Sam actually sell it to? And so what we're going to do now is we're going to go and do from orders to customers, do the join here. Now, how does this work? This is going to be, we're going to be basically looking for where the customer number here as the primary key is equal to the customer number there as the foreign key. And we're probably just going to go grab the last names. So last name and first name. So we go join on customers, which is C, on the idea of the C dot customer number equaling the O dot customer number. So before I start changing my projection, I want to have a quick peek at the actual SQL. Is it going to work? I'm back with 1 line. That's awesome. Now what I'm going to do is going to go C dot last name, or is it last name? It is last name. C dot last name, C dot first name. I'm going to go and fire that puppy off. And now I got myself a nice name. Now, a couple things to make this thing a lot better is this projection's getting a little bit on the long side. So I'd be tempted to start to break it up a little bit. So let's do this, and let's do this, And let's do this. In fact, if I refactor the SQL, it would probably do that for me. And then the other thing is, it's not obvious, is this the customer? Is this the author? Who knows? So what I probably want to do here is use an alias as author, last, or L name, whatever, as author. Okay, move that guy back in. Those now are column aliases. Down here, this would be as cust L name. I'll even just, do that. As cust F name. Next week, by the way, we'll actually learn more about functions and how to make this query even better. But for now, that's good enough. Why? Oh, because there's no underscore there. That's why. All right. So now my projection is going to look a little bit nicer, maybe, right? So there's that. All right. So that was a lot of coding. But I'm telling you, that's pretty easy compared to some of the stuff that is going to wait you out in the real world. So what I want you to see is we've got 1, 2, 3, 4, 5, 6 tables. Those 6 tables will have 1, 2, 3, 4, 5 join conditions. So always keep in mind, some exams actually ask you this. They'll say, how many join conditions would there be in 450 tables? And the answer is going to be 449. It's always one less than the number of tables. Always, 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 always. Now, in older syntax, that was really important to kind of get because, as you saw, all I had to do was slip on another table, and it ran just fine, but it gave me a Cartesian product, right? So, so this one, it's a lot harder to create a Cartesian product in this form. This whole query has only got 2 clauses. It's got the select clause and it's got the from clause. All right. Right here, I've got my little and, which is the thing that's stopping this. But if I, the thing that's only getting Sam, but if I wanted to truly answer the question, that would be basically answer the question. And probably, let's give it a little sort here. Let's go order by, and sort it by basically the last name, the first name. All right, last name. Bang. Okay, so we're getting some pretty good stuff here because what we're seeing in this data is here's Adams. Apparently sold this data implementation book, probably maybe to a class or something like that. And actually, for some reason, is this right? Yeah, there's 2 different dates. I definitely would want to check that out. But you know what? I don't. Yeah, Morales here really liked the book, I guess, because there's quite a few times that this person bought it, perhaps. Maybe they're buying it for someone else. All right, cooking with mushrooms. Jeez Louise. Anyway, this data set never gets old for me. All right, so we definitely would want to verify some of this stuff before we run off to any VPs with it. But that's actually, I don't see anything wrong with this, at least with the syntax. And that's a lot of what the initial part of that chapter was about. So Anthony Andrew joins, join on. Now, just so you know, there's a couple other ways to do joins. So I tell you what, let me just open up another thing for a second. And what we're going to do is we're going to, I won't go backwards because I think you guys will all pull your heads off or start watching Game of Thrones or something. But I'm going to go for customer orders. I'm just going to do this here, where what I want to work out is a different question. I want to know how many customers, or at least what are the orders customers have placed. That's what I want to know. What are the orders customers have placed? So in that query, we're going to start off probably with customers. You could, in theory, start off with orders, but I think realistically, I'm going from the outside in. So I'm going to go select asterisk from customers. And let's just do that. And you know what? So there's our customers. We can do a little bit of anticipating from that previous query. I'm going to alias it as C. I'm just going to grab these. So I'm going to go copy, going to change my projection to be more that, and go C. So, all right. Oh, and maybe we should get that number too. We should get the ID customer number. All right. So C dot customer number. Bang. All right. Good. So there's our customers. We want to know now what orders these customers have placed. If we were in class, I'd be letting you guys do it. I'm just going to do it right here. Orders as O on, and in this case, what's the join condition between those two tables? We're looking in this case where the order as sorry, yeah, that's right, where the customer number is equal to the order's customer number. So starting probably where the primary key is, customer number is equal to the O dot customer number. All right, and let's grab a meaningful piece of information from there. Let's grab the order number and the order date. Let's do that. All right, so okay. Remember, by the way, that there are 20 customers. All right, so I'm going to go grab the customer stuff. I'm going to go grab the O dot order number. Maybe I can get a clerk to look up some information about that, and O dot order date, just for maybe for some financial reporting. So what we're seeing there is a new row has popped up because this person ordered twice, which is good for us, by the way. Probably a better way to do that would maybe be to sort this. But I think we're also seeing something interesting here. All right. I still have you right over here. Oh, that's author. Let's do another one quick. Select asterisks from customers. Okay, make sure you're pinned, and we're going to run this thing. Sometimes, by the way, what we like to do is we have like a workspace here, a window where we just do a bunch of exploratory queries and save the results. I think you can even rename them too. Like for example, here I could have called this thing. This is the customer, cust probably cust, and this is the order line and whatever. This kind of helps us keep track of what's going on. But anyway, so what I want you to see is that this guy, if I do a quick count, I shouldn't have to, but there's 20 rows. Now in here, it looks like we get one more row, 21, which is great. But one thing you should notice is that this guy ordered a couple, this guy ordered a couple, this guy ordered a couple. In fact, you know, what it looks like here is that I don't think all of my 20 customers actually ordered anything, because I've got a lot of duplicates and I've only got 21 rows here, right? So this is a very important point. So if you got bored with joins, come back. This is a very important point. What I'm doing in this query is I'm basically asking for every customer number that is in the order table, basically where customer numbers match. Now I can't remember. We haven't done subqueries, I don't think, right? So there would be an interesting way to show you this in subqueries, but curveball, we can just kind of go back and have a look at customers for a second. So here's 108. 108's there. Okay, who's the one that's not there? 106. All right. So let me just do a quick order. I'm going to show you, by the way, how to do a cheap order, which you'll never do in public. You can order positionally. All right. So never, ever, ever do that. That is bad form, but it's good enough for now. All right. So here, this thing is sorted. And what I want you to notice, look, there's no 1006, even though we actually have a customer 1006. So Messiah here didn't order anything. Now, how could we actually show that in this query? Well, by default, every join you do by default is an inner join. So this is an inner join. What's going on here is that it's looking for every customer that joins with every order. But there's another type of join I could do here. And I could basically do something called an outer join. Now this query won't work, so don't be embarrassed for me. You know it's not going to work. But basically, when I'm doing an outer join, I have to specify a direction. And so what I got to specify here is it going to be every customer, even if they don't have orders? In which case, there'd be a left outer join. I moved the join bit up here just so you can kind of see the left, okay? So the customer is on the left. It could be a left outer join. If I wanted every order that doesn't have customers, which shouldn't be possible in this data set, but if I wanted to see that, I could go right outer join. So let's just go ahead and do the right outer join first and basically see the fact that we're fine. We're going to get our 21 rows, right? Because every order has to have a customer based on that model. But back over to here, if I want every customer that didn't place an order, I want everything on the left, even if it's not on the right. What I want you to know is, first of all, 27 rows. There's some extra rows in here. What are the rows? Well, here's our 106. And here you can get a better appreciation of what null means, okay? Null doesn't mean like, you know, January 1st or spaces. There is not an order number for Misha. There's not an order date. This is the absence of information. Null basically means I don't know. And what it's saying here is I don't know what the order number is for Misha because, of course, there isn't one, right? So that's what null basically means. So, so the outer joins are super important. Now, we don't typically, I mean, I'm sticking with my guns here. I usually would put that on its own line. Left outer join, right outer join. There's another variant of this, and that's called a full outer join, which won't have too much impact here because we already saw that there's nothing on the right, nothing on the left. But there's like basically a full outer join. And to do that in ancient ANSI SQL is actually very hard, which is why, again, you'll be much more valuable if you do this in ANSI 92 SQL. You're not quite ready yet to know how to do it, but actually by the end of this particular discussion, you'll be ready to know how to do it in old SQL. But anyway, so you got basically three types of outers. You got a left, a right, and then a full. Or by default, they can be basically an inner join. All right, I'm going to stop and ask if there's any questions on that. If there's not, I'm going to expose you to another data set because there's one other type of join that I want to show you, and that this data doesn't support that type of join. But boy, should you ever know that type of join. So I think, should I, well, this is recorded, so I guess I don't have to save much of this code. But anyway, okay. So you may have noticed that I've also got another schema ready to go, and let's get rid of the welcome page. I got another schema ready to go, the HR schema. This I love this schema, even though it's an old schema, but it's basically one that was used for a long time to demonstrate some pretty good ideas with a pretty simple data set. That's why I like using it. And over here is the HR schema. Now it looks a little bit harder to look at, but to be honest, we're really just going to focus probably on these tables here. So you get the employees table, which is just a list of all the people. You get the jobs, and later I'll talk a little bit more about the history. And actually, you know what? I tell you what, for this example, I'm just going to stay here. Actually, I'm just going to stay here. So we got basically the employees and we got the departments, and so if I want to basically write a departmental report, so it lists off the departments that list off all the employees. I can't, I'm sure we talked about normalization already, so you've seen this data already. But let's go ahead and do that. Now this one I'm gonna have to go from memory. I don't have the schema up in front of me, but it's not gonna be that hard. We're gonna start off with employees, select asterisks from employees, and let's just go. Let's get some stuff here. So it's first name, last name. So let's grab the department ID, the last name, and the first name, and run it again. Awesome. I'm about to join it with another table. So let's go ahead and add some of these table alias stuff. So I don't have to think about that anymore. Let's do this. Let's do this. And let's do this. So now these guys are going to work just fine. There's a table alias. Let's also, before I go much further, get myself ready because I know I'm going to be going to multiple columns. Now what I'm going to do is I'm going to do my join, right? And I'm going to join where the department ID of departments is equal to the department ID of employees, where the primary is equal to the foreign. One other thing I don't actually want to imply is that there don't have to be any keys here at all, right? But it helps your performance if there are at least indexes on this. And I'll probably try to show that a little bit in a few seconds. So I tell you what, actually, while I'm trying to show it to you, let's run it again. I know I exposed you guys to this idea. I got to move some of this crap around. There it is. All right, and are you showing me everything? I think you are. So there's the cost. So remember, guys, when you're using slightly more sophisticated tools, you're going to want to immediately try and track down what the explain plan is. That's not covered at all in the book, but the explain plan is the thing trying to tell you how it's actually accessing the data, and you can actually work out some performance hints. So in this case, we know that it's doing a full table scan on the employees, which makes sense because I've asked for every single employee. Now, if I was to go where the e.last name is equal to, I promise we'll get back to joins in case you're sad, but oh boy, do I have results? Do I have query results? Okay, so King. We're going to go for King here. So the last name is King. All right. Now, what's kind of cool here, where is it, right? You don't even have to run the query to actually test that out. It's telling me right now what it's going to do. And apparently there's an index on the last name. That's awesome. Good. I didn't actually know that. All right, good. So let's do another quick restriction then. So let's go over here and see what else I could, oh, over here, not over here, over here. What would be a good thing? How about the hire date? Sure. Actually, the salary. Let me do the salary. I know the salary a bit better. So I'm not going to go where the last name's King. I'm going to go where the e.salary is greater than, let's just say, like, I don't know, 3,000. Okay. And I'm going to, again, test it out. You'll notice now there's no index, right? No index being used on that. So it's doing a full table scan and doing that. Okay, cool. Now let me go ahead and do that join thing that I want to do. I'm going to go join with the departments D on the condition that the D.department ID is equal to the E.department ID. All right. Let's do the explain plan first to see what's going to happen there. And oh, that's really neat, actually. That's very interesting. So I'm going to run it first of all, see what's going on. There's my data back. Good deal. And by the way, maybe I should probably be thinking about putting the e.salary in there so I can see what it is. And then right after the, right after the department ID, let's put the department name. And also said E there, that's bad. So push you over, put a D there, and put a comma at the end of this. Go. Awesome. Any idea where I went wrong? No comma there. All right, go. All right, so that's pretty cool. And yeah, anyway, it's kind of neat to sort of watch what's going on here. Here now, for some reason, now it's back to using the it's using an index now, right? So and the cost has been getting, of course, more, but it's not nearly as much as it would be if there was an index, right? So all right, so far you're thinking, okay, Grant, aside from the index crap, what is the point of telling me this story? Here's the point of telling you the story. So let's let me add a quick order by it first. Order by and the again, order by one. Don't do that in real life, but that's what I'm doing. It is coming out in that order, but that's an accident. So I just want to make sure. All right, so we know that this guy has got 106 rows in it. 106 rows came back. If I go and I just do a quick sanity check, I go select asterisk from employees, and I go and say how many rows are coming back. There's actually 107 employees. So you have 107 employees, yet only 106 came back. What does that tell you when you're looking at this data? 107 employees, yet when we combine them, we only get 106 back. You know, I have a buckthorn farm in my backyard. You guys can come back and hack some of that down. We can talk about keys. All right, here's the deal. What's going on? What it's telling us is there's at least one employee, not at least, there should only be one employee that doesn't have a department number. Or, well, the legalism here is that this guy does not have a department number that's in this table. That's the absolute truth. But because there's other stuff going on in here, we know that we can't have a non-existent department number that doesn't match. Oh, look at that! There's chats going on. Well, you guys have been answering. So, okay, so cool. A couple questions came up in the chat, but let me just get the point. Yes, it's correct. Basically, somebody doesn't have a department number, or again, absolute legalism. There is a department here that doesn't exist there, which is the case. Like if you don't have a department number, that the department number doesn't exist. So to fix that, what we want to do is we want to go and do a join. So what kind of join would we want to do? Would we want to do a left, or would we want to do a right? I will totally pay attention to the text. I'm watching the chat right now. We want every employee, even if they don't have a department. What kind of join would that be? So awesome. I'm seeing the two kinds. So here's the deal. If you want every employee, even if it doesn't have a department, you actually want everything on the left. And so let's just do that and run that query for a second. And what I'm expecting to see right down there is Kimberly Grant doesn't have a department number. Now, that's cool. It could also be the case, by the way, that we have departments that don't have anybody. So let's go right. So in this case, it'd be asking for everything on the right, even if it's not on the left. And this is really interesting when you start watching it, because we start to see a bunch of, oh, by the way, let me use the actual key from the departments table. So it's not quite as awesome or gross as that. So now we're starting to see departments that actually don't have anybody in them, right? And then if you want both, there's the full. And this would list Kimberly somewhere probably at the bottom. No, yeah, there's you. Kimberly's at the bottom, and then all the departments are at the top. Now, that's awesome, and that's sort of a tiny bit of a sort of review for left, right. But the reason I brought you back here is I want you to see this relationship. And please don't let me end this conversation before I answer one of those questions about, is ANSI 92 used more? Actually, I'll just answer it now. ANSI 92, is that used more in the IT world? So it's been around since 1992. It does have a lot of acceptance. I'd say, sadly, a lot of computer-generated SQL doesn't use ANSI 92. It just uses the old stuff. But at least, you know, when I was reading articles on this kind of crap, it was definitely the preferred way to code. And I know my team for like the last 15 years at Oracle was using ANSI 92. So, so there you have it. And we actually had at one point a big conversion effort. Like whenever you were maintaining something, and the code kind of came through. You wouldn't just fix the problem, but you'd actually convert the code to 92 so that we could see some performance increases. So that's why I'm kind of trying to evangelize that. And Khalid gets the award for this thing. This is actually a recursive relationship. Let me show you the recursive relationship. And of course, I have shown this quite a few times now in other courses, but it bears repeating here, right? So this is why I get really uptight about the whole foreign key definitions that show up in a lot of books. Foreign keys typically say that it's a primary key that points to the, it's a key that points to the primary key of another table. That's typically what you see. And you can kind of see that here, right? Here's the primary key. The foreign key is pointing to the primary key of a table, of another table. That's what the definitions typically say. One of the things I always like to add to that definition for sure is that the foreign key doesn't have to be populated. The primary key always needs to be populated because the primary key uniquely identifies a row. Foreign keys don't uniquely identify a row. They just point to the primary key of a table. That's all they do. And if you don't have a foreign key, that just basically means that there is no row in another table that matches this. So the value, if it exists, has to point to a primary key. But the second thing is this guy here. So when we look at that diagram, it's recursive. What's recursive? What's recursive is that Nina here, Nina, her manager is 100. Lex's manager is also 100. Who's 100? Steven's 100. So this is actually a foreign key. And you'll actually see that in the design. It is, the manager ID is a foreign key. And what is it? It's a foreign key that points to the primary key of its same table. It's pointing to the primary key of its same table. Now, these are not super common, but they aren't like, like purple unicorns either. I mean, they are actually out there quite a bit. There's a lot of recursive relationships in data. So this was important to me to discover. And again, this is one of those things I painfully discovered on my own before I was classically trained on it. Because, a very, very young Grant, if he wanted to have a manager table, he would have been tempted to have an employee table that looked exactly the same as the employee table, but that would have been just for managers. That's what a very, very young Grant would have done. But in this case, there's no added information to being a manager. A manager just happens to be an employee whose number basically appears inside the manager ID. So if I wanted to basically get Nina to show up in the same row as Stephen, how would I do that? And there's a reason I'm talking about that right now in the joins chapter. And I don't think the book covered this. So this is why, or if it did, I didn't see it as I was going through it. How would you join a table to itself? Because doing a self join is kind of an important skill. So first of all, if I, right now what I'm trying to say is I would like to have the first name of the employee, the first name of the manager, actually probably the first name of the manager, first name of the employee. From there, join, oops, please get that S back, put the E back. Join on employees, so join on employees on the condition where the employee ID is equal to the manager ID. Now, I hope that you're confused because this is hard for me to type. This will not work. This query itself will have absolutely no problem running, but it's not going to produce any kind of meaningful results. Right? I mean, aside from the ambiguous problem, I'm actually asking where an employee are their own managers, and that's not cool. So, how do you join a table to itself? You need to have the aliases. So I'm going to call this guy emp. I'm going to call this guy mzr. Now this query starts to flesh out a little bit more. I want the manager's first name with the employee's first name, where the manager's employee ID is the employee's manager ID. All right, and man, I tell you what, let me also do this quickly, where the employee IDs, and I'm going to order by that using that crappy method that you're never supposed to use. Order by one. All right, go. Okay, so here's Steve with Nina, Steve with Lex, and that's kind of what we saw on that data. Now, let me do a quick count. 106 rows. Why do I only have 106 rows when I actually had 107 points? Looking at the chat. There's only one brave person out there. Major, you gave the answer last time. It's almost the same answer. Right? So one person doesn't have a manager. Thank you, Thomas. One person doesn't have a manager. All right. So the CEO doesn't have a manager. So here's the deal, right? In this universe, the CEO doesn't report to anybody. We go select asterisks from employees and just have a quick peek at what that is. There's no manager ID for Steve. So how do we get the manager ID? Sorry, not the manager ID, sorry. How do we get Steve on the report is kind of the question. How do we get Steve on the report? And what we'd have to do is we'd have to do another outer join. What kind of outer join? We're going left because, as Major said, we're going left because we want every employee, even if they don't have a manager. I think left is a great guess. I'll buy you a Coke if this is wrong. We're going to go, and there he is. Steve does not have a manager. By the way, what would have made this query a little bit better is if I would have used the aliases here. So let's just do that and go and do this, and maybe let's move the employee ID out and over to here. There, I think the data will look slightly better now. Oh, order by one. Do you see why we don't do that? We don't use positional things because of just those kind of reasons. Anyway, all right, so there it is. So so there's Steve with no manager, but here we got this Stephen is managing that person, Lex is managing one person, Alexander is managing these people. That is a self-join. All right, and oh, and it's bad form for self-join. So let me just do this for a second, and let me do I'm sorry, by two. I will capture this. I'll put it into the section. Okay, so because I'm recording this, I can't necessarily stop for a bit of a break. But the good news is we are probably, well, we do have actually one sort of major topic. So following this, because I got to talk about sets. And the reason I want to talk about sets slightly deeper than the book does is because I actually made a significant amount using this kind of technology, and I think it's underused. So it's certainly understood. So what I'm going to do is I'm going to pause the video. That's what I'll do. I'll pause, and we're going to have a 10-minute break while I set myself up, and then we're going to start up again at 20 after. That's what I'm going to do. I'm going to keep it going. If you got any questions, I'm not actually going to get up. I'm just going to pause the video and start it once I'm ready for sets. So, all right, we're back. One of the things that came up during the break was sort of a question about self-joins and all that. And it reminded me that, first of all, in our materials area, I do have links, and I've kind of forgotten about them, to be honest. But there's the live SQL link, the Apex and all that. But this is kind of a cool one too. We actually have a link in there to W3 School's SQL. Now, the SQL here is actually pretty good and even runnable. So, for example, let's pick the left outer join here. So left outer join, they'll give you a nice little diagram. So it's everything on the left, even if it's not on the right. So it's including that set. They give you a little database. They give you sort of an example. And they're saying here, this will select all customers and any orders they may have. And so we got customers, left outer join on this. They didn't use table aliases, but whatever. The cool part is you can click on the try it yourself. You can actually run the SQL, and it actually runs, and it actually is running the SQL. If I change this thing and alias it, so I've changed the SQL now, and I go, it ran, and if I, let's just say I go as order number, so I just as order, and I go. So it is running. So it is, a pretty neat little sandbox to try some stuff out. And then the thing that I wanted to show you too was the self-join. What was the important part? Oh, I know the important part of the self-join. This was sort of another example of a self-join. And I realized that the one I gave you is pretty good, right? The show me all the managers and their employees, right? That's the standard one. This is another kind of case because I think colleague was asking me kind of how often these are done in the industry. And one thing you will notice as you start working more with SQL is that you can actually sometimes answer the same question in multiple ways, right? So here's a neat question. Match, basically grab all the customers that are in the same city. So what I'm going to do here is I'm going to run this query and just run it. And I'm going to grab this guy, Cactus. All right, and I'm going to put that into the where clause. Now, they did not do this in ANSI standard, but you know what? It's such a cool product that I'm not going to get mad at them. So we're going to go a.customer name. I'm just doing a projection here, or sorry, a restriction. Is equal to that and that. All right, let's just try that, and that worked. Okay. So what you'd recognize right away is we're trying to find customers that are in the same city. So basically, there's sort of our two tables. There's our join condition. But sometimes, you know what? No, I can't. No, I can't. Sorry, guys. Just give me a second. It's irritating me. Join on, and let me just put that restriction or the join condition there, and then we put that into the and. Okay, so I'm just moving some stuff around, and let me put you up there. So what happens when you get old and cantankerous? All right, so well, actually I could have left it there. It's all part of the and. Okay, move you over. Move you over. First of all, will you work or have I destroyed you? Nope, you'll work. Okay, good. All right. So this is pretty cool, and this is the way I would have written that query. But what I wanted you to see is what happens without the middle restriction. All right, so I'm going to go. So what happens without middle restriction is that Cactus is in the customers table. Cactus is also in the customers table. And when you do a join the table to itself, and you're not like looking for, for example, families on the same account or students in the same class, that kind of those kind of things. You got to make sure that you have an extra special restriction in there, basically saying that I want customers in the same city, but that are not the same person. And that's what that line is there. It's very, very, very cool, and I'd strongly recommend that when you're less tired, that you go and have a peek at this particular query, because it's an important one. Because when I'm asked like how often, I kind of given you already a couple of examples, right? So this one is customers in the same city, students in the same class, people that have the same manager, people that have the same job. I mean, there are a couple ways to answer that question in SQL. One is using this technology, another one is using subqueries, right? So it's just important to kind of get that idea. But the other important learning thing is look. There's an example of a where clause. There's an example of an order by clause. All this stuff should be right out of the book. There's a like in case you've forgotten that. And this is an Oracle site. This is ANSI standard SQL. So what I've been trying to tell you guys is that I'm not trying to make you guys into Oracle progeny, especially now. Just kidding. I have no bitterness to the company, just a little bit. But my purpose here has always been to try and make you guys, functional in any relational database. Now, some of this stuff, like this select top, never seen that before in an Oracle database. Doesn't necessarily mean it doesn't exist. I just haven't seen it before in an Oracle database. But this might be something that works. In fact, it's telling you right here. It's working in those two technologies. Whereas if I go delete works everywhere. Okay, so it's a good site to look at. Please, please, please go ahead and do that. Because you're an Oracle database, mostly using an Oracle database, that's also, this is overkill for documentation. Quick question from Henry was, using Live SQL a good way to test out your final projects? Of course it is, absolutely. It's a good place to do your actual assignments too. Live SQL was meant to be the default database available for absolutely anybody, especially people that either didn't want to or could not get the virtual machine. For those of you that just simply couldn't get the virtual machine running, don't worry, because I mean, it's a pretty intensive beast, and some of you, if you're running like on, I know none of you are, but if you're running on like a 4 gigabyte, laptop that you got from your parents, it's probably not going to work. So, but if you happen to be, I mean, the only reason I can run this software stuff at home is because I happen to like the game, and I like to have a machine that can handle some games. So because of that, my machine, because it can handle games, can also handle some of this software. So the PC I've got here is it's a 16 gig machine, and anyway, and it can handle it. And yes, Adam, they do have VI, and they even have Vim, and they even have I think gedit. So yeah, you go ahead, go nuts, and have fun with that. And if you want to have a VI cheat sheet, I actually have one of those somewhere buried deep in my stuff. But honestly, I don't even know why I'm telling you this, because of course, why go to some decrepit instructor when you can just go cheat sheet and get it like that? Yeah, that's probably, there you go. VI, by the way, stands for visual, shoot, I forgot what it stands for. Visual editor? No, not visual editor. Okay, whatever. Someone can tell me that later. It is the fact that Adam wants to actually use VI just shows how much he hates himself. So anyway, all right. So actually, by the way, for the record, it does make Adam more marketable though, because VI isn't going away anytime soon, right? VI is definitely out there in the Linux world, and I learned it in the Unix world, so it's definitely a thing. So so if you're going to be pursuing a career like you network people, if you're going to pursue a career where you're dealing with machines and you want like command prompty kind of stuff to do, you're definitely going to want to know how to do VI. All right, now that was all bonus material. As far as the last idea I want to share with you, is this idea of sets. And actually, you know what? Before I leave this has probably got it. Why even do that when it's probably even got pictures? Do you have a picture? Oh man, you used the circles, but you didn't use the circles here. Oh, all right. Hang on a second, guys. I'm sorry, but I'm bringing up the equivalent of a whiteboard. Yeah, this would have been the thing to have done during the break, but whatever. All right, so let's do that, and let's do the 2 circles. So let's get rid of you. So I want you to pretend that you're all staring at me as I draw up on the whiteboard, and I basically have a circle here, and then I have basically a circle here. Some of you guys have seen this. If you're in another class with me, I'm sure I did something like this in the other class. So I do a circle there. All right, good deal. That's what I'm going to do here is I'm just going to go in quickly and do a little bit of quick formatting on this thing. Formatting on this thing. Where's my format? Right there, format. Can't believe you can see it. Thank you. The fill is none. And over here, the fill is none. And now what I'm going to do is I'm just going to grab a bunch of numbers. I'm going to make this 1, and I'm going to make it 2, and I'm going to make it. Did I do this with you guys already? Did I do a set? Stop me, or you're going to get it again. All right, I can't remember. All right, so here's basically this idea of the set. So in this set, I've got the numbers 1, and I've got the numbers 2, and I've got the number 3. And in this set, I've got the number 4, and in this set, I've got the number 5. And I'm saying in this set that this is set A, and this is set, oh my goodness, dropped off. And this is set B. And let's just do this. Oh, nice. Cases is different, but that's fine. Up, and move you up to here. All right, so I got basically 2 sets. There's set A, and here's set B. All right, so I always like to make the joke that this is all stuff that you would have learned basically in elementary school, right? So if I wanted to know what is in set A is basically 1, 2, and 3. That's what set A is. And what is set B? Set B is 3, 4, and 5. That's what set B is. Now set A, now it's actually a U B. So what is that? That's basically union. It's kind of like a plus. It's like taking this set, and it isn't really adding the set to the other set. That's a whole other thing with linear algebra, and I don't want to deal with that. But it's taking the union of this set, A and the union of B. So the set A union with B is 1, 2, 3, 4, and 5. What I want you to notice is not 1, 2, 3, 3, 4, 5. It's 1, 2, 3, 4, 5. That is a union. Now, if I go set A minus B, right? So let's set A minus B. It's going to be basically this set with this set taken out. So it's going to be 1 and 2. Helicopter is now flying over my house, by the way, making me kind of glad I wasn't watching Walking Dead. That's set A minus B. Okay, and then the other thing, which I have to admit, I've forgotten what the symbol is for it, but it'd be basically something to the effect, oh, I know what it is. It's yeah. So it's actually supposed to be like a U upside down. It's basically an N, right? I can't do a U upside down. I could if I dragged up the character map. But anyway, this is A intersect with B. So this is basically 1, 2, 3, 4, 5. What is in common? And that is basically 3. All right. So that's the, so this guy, sorry, what was this? This was basically intersect. This was minus. And those ideas live in SQL. They live in SQL. Let me show you a quick example of that in my own data set. So, and for that, I'm going to show you the employees table, which I've got already, and this job history table. This is one of the best examples I've ever seen. That's why I like doing it, because they're two tables you don't think they have a lot structurally in common, but they actually kind of do. So select asterisks from job history. So the employees table you guys are bored of looking at, but let's look at the job history. So in job history, you can tell that employee number 102 from this range was a programmer. Perhaps someone slightly more interesting is 101. 101 in this date range was an accountant. 101 in this date range, which is like the next day, see the 27th, 28th, was the manager. And then, let's notice it's 101. 101 is now a VP. So what does that tell you? The employees table has got all the people in their current position, and the job history table have all the employees in, not all the employees, but it's got employees who have changed jobs, right? They've got employees that have changed jobs. Now this example, although it's academic, is totally ripped out of Oracle processing, right? Because when I had to write a query to basically sort of prove, like not prove, but show my own lineage, my own history, I did something very similar to this query, right? So that's why I think it's important to show you. All right, so, and remember, by the way, you can duplicate this because I think in the live SQL, because of that script in there gives you the HR tables. I can't remember what it's called now, but it's there. And of course, if you've got one of these virtual machines, just basically find the HR schema, and you can do it here too. All right, so what I want to do is I basically want to grab Nina, and I want to say, well, what actually is her job history, right? So let's make myself another thing and get Nina's job history. So if we look here, it looks like we basically need, we basically want this information, maybe even this information actually. So what I'm going to do is, I think actually, can I do this? This is kind of cheap, but I think I can right click and copy the column headings. Yes, I can. Good for me. So I'm going to go select this from job history. Boy, can I type fast. Anyway, so there's that. Oh, except where you're needed. So where the employee ID is equal to 101. So this is showing me all of Nina's stuff. I'm gonna go semicolon. I'm gonna quickly pin it. Now I want the same kind of thing for the current table. So I'm gonna go select employee ID. The start date, I'm gonna go as hire date. I don't even know if that's actually accurate, but I'm going to do it anyways. Hire date. By the way, was it hire date with an underscore? Does anyone remember? Hire date's got an underscore. All right, hire date. The job ID and the department ID. This is all going to come from employees. Let's go and run it. Bang. Okay, oh, sorry, where the employee ID is this? Copy it. I just want this stuff. All right, cool. Go. Okay. Yeah, I'm a little bit worried about my assertion here because really, you know what? Because look, sorry, if you just look at this for a second, 21 of September 89 is when she was hired. So we'd have to basically know that, but we could do this, and I'm not ready to do it now, but we'd have to basically know what the end date was before, like add 1 to it basically. So you know what I'm going to do at this point, just because I don't want to deal with it right now, I'm just going to take it out. Maybe if you're really lucky, I might stay up and come up with that example because it is kind of cool, but it's using a special kind of functions. I want to talk about those functions a bit later. So let's just do this instead. I'm just going to do this with the job. I'm going to go. Okay, so this guy, there's Nina being the VP. And then if I ran this query, here's Nina's 2 positions. Do you see how I could maybe now combine these? This is like one circle, right? And this is like the second circle. And what I can do is use a union here. And there you go. So I actually have Nina's entire job history up on the like in one query, relatively speaking. What happened here is that this query ran first, producing this data set. Then this query ran and was put on top of that data set, or wherever it was, like a snowball. And then we can go. And now that's the entire job history. Now, excuse me, it doesn't make any sense to do it like this, but if I wanted to go and union this with like 100, for example, the business logic doesn't make any sense. But I don't think it's COVID. Who knows? Let's just do this and go. Now what we're going to get is there's King being added to it. Now that is sort of a union, and it's a pretty decent example where I'm actually pulling data from more than one table. I have to make sure that the data that's coming out is of the same format. Okay, it's of the same format. So you know, actually, one thing I could do is I could go. No, I still can't do that. Yeah, I still can't do that. Never mind. Forget it. Okay, so that's one example, and that's a union. So a union basically it takes one set and combines it with another set. Now I can do a minus. Let's just see. I don't know if I have enough business knowledge to basically try and figure out the minus. Yeah, I don't know. I think I'm gonna probably just stop right there. Maybe I might come out with other examples with like, you know, minuses and union alls and all that kind of stuff with this. But this is actually a pretty classic example of using a union. One thing I will tell you is that there is such a thing as union all. And I think the best way to show you that is in a super academic way. But let me just do this for a second. I'm going to go select A from dual. So what does this do, guys? It's just going to basically give me the literal A up on the screen, right? So there's A down here once you run it. Once you run it, there's A, right? Good deal. Actually, you know, we can actually replicate that actual example. So let's go, here's one. Oh, all right. So there's one. I'm going to go copy, paste, 2, 3, 3, 4, 5. Okay, so 1, 2. Nice. Thanks for helping me out there. 2, 3. That was the first circle. 4. No, second circle started with 3. Started with 3. Again with the dummy. Thanks again for helping me out. 4. Click over here. 5. Okay. If I ran that as a script, by the way, no surprise, you're just going to get those, right? That's the result. Now, what I'm trying to show you is that, hey, look, I can go union, copy, and take that set, combine with that set, combine with that set, put with spaces, combine with that set, and combine with that set, and go. And now what I get is 1, 2, 3, 4, 5. Pretty cool, right? And what I guess I could do if I wanted to was actually really make it. Let's try this one. If I did that query, no, that's not going to make any sense. By the way, you can use parentheses here, just so you know, but why complicate that? Anyway, see how union suppressed the duplicates, even though I got 3 through 3? If I go all, which is another guy, so union all, and let's copy that a few times. Copy, paste, 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 and paste. What union all does is it does not suppress duplicates. Another thing that union all doesn't do is it doesn't sort. Watch this. If I run this query exactly like that, you get, oh, got to be on the inside of the query. You get 5 down to 1. If I took out the alls, it would not only suppress the duplicates, but it would actually sort the data set. So why in the world do I waste my time telling you this stuff? This is why. So this example here, as I said, is right out of Oracle, and that's great. But an example that we had as a team, again, a younger grant, but what I had to do is I had to combine order data from one data set with accounts receivable data from another data set. And they each, by the way, each data set was almost a page of SQL, right? And I basically had to combine them in the end. That's how we decided to sort of solve a particular problem. First thing I had to do was I had to basically make sure that the columns lined up. And so if there's a column here, like for example, let's say hire date, not hire date, is that the employees? Not the employees, it was start date or end date. Let's just go end date. Okay, so I'm looking at the end dates here. So I go. This query is no longer going to work. It's going to say, dude, your columns up here, you got 4, but you only got 3. You got to fix this. Now, one thing I could do to fix this is just put a null in there. And then once I fix it like that, then it works because she doesn't have an end date as a starting VP, right? So, sorry, as a VP. So that's one thing I had to do. I had to take my order data and sort of line it up, and the accounts receivable data lined up, and the areas that they matched were great. Areas that they didn't match, I basically put nulls over here, and I put like nulls over on this side. I don't know what a good null would be there, but anyway, like manager maybe would be a good null. So that was a pretty cool idea. But the other problem was I didn't want any duplicate suppressions because you know what? This query here, when it had all the alls in it, this query ran a lot faster than the query did with the alls, without the alls. because without the alls, it sorts and suppresses duplicates. And so I was looking at like millions of rows coming into this thing, and I didn't want to have to deal with it sorting when I didn't want the data sorted in the end. I just want all the order data plopped on top of all the accounts receivable data. And then eventually what we started seeing is then I plopped it on top of some other kind of data, and then I plopped it on some other kind of data, and it became known as the spine, with each one of these queries being a vertebrae. And it was ultimately what we started building our entire data mart off of. So it was a pretty valuable thing. It was a Grant Smith original. I came up with it. It was perfected by many other people, but it was all based on this idea of sets and the fact that I was familiar enough with sets. And I'm glad that, you know, that it just solved some people's problems, unless it had nothing to do with it. But anyway, the set stuff in SQL is just something that people kind of sometimes just forget exists, but it is there. There's a set, and I wish they got the union, but they don't have intersect. But anyway, just remember you got union all. I don't know why they didn't bother, but there's the intersect, and then there's the minus, and those are all kind of important. And I might actually show you some of that later. All right, I'm basically done the actual lecture part. I'm going to stop the recording now, and I just want to talk a little bit about the assignment. So let's just pause that. Actually, I'll probably just stop.